Hi, I'm here to discuss to you about RIP routing protocol. So, what is RIP protocol? It is one of a family of IP routing protocols, and it is an interior gateway protocol designed to distribute routing information within an autonomous system. So, as you all know, there are two types of routing protocol. One is interior gateway routing protocol, and one is exterior routing protocol. So, the only exterior routing protocol right now that's being used is BGP, which is similar, sort of, in a way, with RIP. So RIP is a simple vector routing protocol with many existing implementations in the field. In a vector routing protocol, the routers exchange network reachability information with their nearest neighbors. In other words, the routers communicate with to each other the sets of destination address prefixes, which are they commonly called, that they can reach, and the next hop address to which data should be sent in order to reach those destinations. This contrasts with link state IGPs. Vectoring protocols exchange route with one another, whereas link state routers exchange topology information. So um, link state uh, protocols are like OSPF and ISIS and calculate their own routes locally. A vector routing protocol floods reachability information throughout all routers participating in the protocol, so that every router has a routing table containing the complete set of destination known to the participating routers. So another word that they call uh, RIP is routing by rumor. So in brief, the RIP protocol works as follows. Each router initiates its routing table with a list of locally connected networks. Periodically, each router advertises the entire contents of its routing table over all its RIP-enabled interfaces. Whenever a RIP router receives such an advertisement, it puts all the appropriate routes into its routing table and begins using it to forward packets. The process ensures that every network connected to every router eventually becomes known to all routers. If the router does not continue to receive advertisement for a remote route, it eventually times out. That route eventually times out that route and stops forwarding packets over it. In other words, RIP is a stop state protocol. Every route has a property called metric, which indicates the distance to the route's destination. Every time a router receives a route advertisement, it increments the metric. The router prefers shorter routes to longer routes when deciding which two versions of route to program in the routing table. The maximum metric permitted by rep is 16, which means that the route is unreachable. This means that the protocol cannot scale to networks where there are more than 15 hops to a given destination. Next, we'll discuss about the timers. So the routing information protocol uses the following timers as part of the operation. Update timer controls the interval between two continuous response messages. By default, the value is 30 seconds. The response message is broadcast to all enabled interfaces. Invalid timer. The invalid timer specifies how long the routing entry can be in the routing table without being updated. This is called an expiration timer. By default, the value is 180 seconds. After the expiration, after the timer expires, the hop count of the routing entry will be set to 16, marking the destination as unreachable. Flashdown timer. The flashdown timer controls the time between the route is invalidated or marked as unreachable and the removal of the entry from the routing table. So by default, the value is 240 seconds. This is 60 seconds longer than the invalid timer. So for 60 seconds, the router will be advertising about this unreachable route to all its neighbors. This timer must be set to a higher value than the invalid timer. This obviously because it removes the routes from the routing table already. And hold down timer is started per route entry. When a hop count is changing from a lower value to a higher value, this allows the route to be stabilized. During this time, no update can be done to the routing entry. This is not part of the RFC 1058. This is only a Cisco implementation. So you have to be very careful if you're going to configure this because it is only a Cisco implementation. So other devices will not have this option. So the default value of this timer is 180 seconds. Versions of RIP. So RIP has two versions, RIP version 1 and RIP version 2. So for RIP version 1, it is a classful protocol. It doesn't support vulnerable length subnet mask or BLSM. Doesn't send subnet masks with periodic updates. It uses broadcast, which is 255.255.255.255 to send the periodic updates. It doesn't support authentication. Doesn't support manual summarization. For RIP version 2, which is the opposite, it supports classless and support variable length subnet mask or BLSM. So let's say you have a class A address. You could make this host or the host smaller, or you could use a value more than /8. It sends subnet mask with periodic updates, and instead of using broadcast, it uses multicast, which is 224.0.0.255 to send periodic updates. Supports authentication, in which you could put a password on the routers in order for it to participate in the routing updates. And it supports manual summarization. So next, we're gonna do a lab. So this is the network. This is the network diagram that I prepared. So it has 4 routers and 2 hosts. And the IP address for those are here. So for this one, it specifies all the ports and the loopbacks, as well as the IP addresses for the host. So let us begin. Here's the console for Atlanta. So normally for Atlanta, I started out first with putting the BTY lines on the configuration so that later on um, I could tell it into the device rather than using the console to configure it. Put the password on it so nobody could log into it without knowing the password. And put the option to log in. It's very important that you put in that because you cannot log in without that. Then we'll start doing the interfaces. So start doing the loopbacks first. So a slash 25 is right. And then normally just a habit, put another shut on it. So I configured the rest of the configuration using a notepad so that I could just copy and paste the configuration so that the video will be shorter. Okay, just make sure that there are no errors that pop up when you copy and paste it. Just to make sure that it accepts the configuration. Next, we'll configure the RIP configuration. So router RIP. So we put in there version 2. And then for the networks, we have three networks. 192.168.1.0, 192.168.102.0, and 192.168.122.0. Just arrow up on it. Then, last but not the least, we'll configure the timers. So, timer basic, and then what are the options? Uh, First, specify the updates. So, instead of putting um, the default, we'll just put it at 5 seconds, make it shorter. Then, next one, invalid timer. So, we'll make it shorter. Then, hold down. And last but not the least is the flush. And that's it. Okay, so like what I said, I have pasted all the configuration for the other routers, or I did it on a notepad, so I'll just copy and paste it. X. Then last but not the least is ORD. So forget the elements here. From there, we could check if it accepted all the routes. So you do a show IP route. So for here, ORD, you should have three connected one slash one dash internet three dash zero. The two loopbacks there, and then the flash. You can insert this here. And then for the other ones, so you just casually observe it. So it would be able to see the 1 to 2, 1 to 2 network. Here, which is and then the 150 for the loopback on Boston. And, and then 2 and then the /1. /103. 3.0. And the 4.0. Okay, and then let's start pinging the addresses. So uh, should be able to ping the host from here. So let's ping closest one to it, which is the CentOS. So ping the 101 or the 1.1. Three that one, 4.1, 102, 103, 150. Oh, but the tricky part for the 150 is I segregated it in such a way that it's slash 26, which is 64 hosts network. Then if we look at Atlanta, which is on the opposite side of the um, network, and do a show IP route, you should have the same amount of network connected to the appropriate group. So on the next video, we're gonna dive deep more on further configuration for this, and then we'll do a Wireshark demo on how to spot the RIP updates from Wireshark and some troubleshooting guides. So thank you very much for watching the video, and I hope you subscribe.